In this video, we're going to talk about the law of sines. Now remember, the law of sines is a calculator required lesson. You will not be able to do this without your calculator. On your calculator, you want to make sure you're in degree mode. We'll do that when we get to when we need the calculator. Okay, law of sines. The law of sines is a way that trigonometry can be used without the need of a special right triangle. I like to write LOS for law of sines as an abbreviation, so if you see that, you know I'm using this law. The formula can be used with any side and any angle. It's important to realize that if it's a capital letter, that represents an angle, so you'll see that right here. And if it's a lowercase letter, that represents the side. These are always labeled in alphabetical order. So when you would label, you'll label them as A, B, C, or P, Q, R, whichever variables you choose to use. It's important to note that the formula should not have two equal signs in it. You'll see here that it's used with any two ratios. Okay, so that means you can evaluate sine of A and sine of B and sine of C, whatever your relationship is, but only two at a time. This formula allows you to find the value of a missing side or a missing angle of your triangle. Here's how the law of sines works. It definitely has an application back to geometry. You'll see that in the law of sines, you have ASA. Now, if you remember what that means, that's angle, side, angle. It was definitely a reason for proving triangles congruent. We're not doing anything related to proofs, it's just the relationship of the values. So let me show you what an angle, side, angle would look like. That would be angle A, side B, and angle C. That's an example of angle, side, angle. If I wanted to do side, side angle, that would be a situation where I have to make sure that I have two sides with the included angle. So in this situation here, I would take that back. I would have two sides with the angle opposite one of those sides. So I'll do that in pink so you can see that one. So that would be side B with angle B. That's the angle opposite the side, and then maybe a side A. Okay? One thing to keep in mind that when you're talking about capital A for angle A and lowercase a for side A, when you're looking at your triangle, we want to know that if this is angle A, directly across from it is side A. Okay, that's how the relationships will work. So if angle B is at the top, directly across is going to be side B. Same for our final angle and side of the triangle. Okay, so let's jump in and see what we can do. Notice here that it just says given triangle ABC. It doesn't tell us it's a right triangle, and that's the difference. Okay, so here we're going to usually have no right angles at all. You are always going to start with a picture and label everything you can label. It never matters which is side A, side B, side C, they just need to correspond. So in my picture, it's not necessarily drawn to scale. You'll see that this is 103 degrees in my picture. In yours, maybe you want to make it actually look obtuse. Angle B is 28 degrees. A little bit more accurate right there. And side B is a length of 26. Okay. So to use the law of sines, we need to have one of those two relationships. So you'll see here that you have angle B directly across from side B. That's one match. We like a match. Then you have angle C. So the only thing that you can find with angle C is the value of the side directly across from it. So the first thing we're going to be doing is finding side C. They are reminding us in our question, we're rounding to the nearest tenth. We only round the final answer. So from the law of sines formula, we're going to say the sine of angle B over side B equals the sine of angle C over side C. Fill in what you know. Angle B is 28 degrees. Side B measures 26. Angle C is 103 degrees. Side C is unknown. This is a proportion. We can solve our proportion by cross multiplication. So we get side C times the sine of 28 degrees equals side B of 26 times the sine of angle C of 103 degrees. Divide by the sine of 28. Once you have your proportion simplified, you can go ahead and go to your calculator. So in our calculator, we're going to type in this entire proportion in one shot. That way we have no rounding errors to solve for side C. Okay, first thing you're going to check on your calculator is you're going to check to make sure that you're in degree mode. See, I'm pointing up here, it says DEG. I know that I'm in degrees. If you're not, you come over here to the home, you go to number 5 settings, number 2 document settings, and you make sure that this angle is in degree form. Make it your default so it stays set in degrees. Okay, let's type in our proportion. So here we are typing in 26, 26 sine. I go to my trig button, I get the sine function of 103 degrees. That has to stay in parentheses. I don't need the degree symbol here because I already have my calculator set in degrees. If you are set in radians, then you would need that actual degree symbol. We're going to round our side to the nearest tenth. Looks like the 6 bumps the 9, which bumps the 3. So side C has a length of 54. So that's my first piece of information in my triangle. The next pieces of information is anything to do with angle A and side A. You'll notice right now we don't have either of those. But angle A should be the next thing we find because we remember from geometry that 3 angles in a triangle add up to 180 degrees. So to get angle A, we're going to say that 103 plus 28 is 131. Subtract that from 180. That tells me that my missing angle is 49 degrees. Now I can use that angle, to help me find sine. The sine of 49 degrees is going to help me find side A. So once again, I set up my proportion. Now, when you make this proportion, since you already know B's and you already know C's, you really get the decision as to which you want to use. My suggestion is use the given, which is side B, angle B, because there's no rounding error there. So I'm going to do the sine of angle A over side A equals the sine of angle B over side B. I keep writing the formula so that you realize how it's used, and it's going to help you remember it the more you write it. But eventually, we're just going to plug right in. Cross multiply again. Divide. And then into our calculator, we'll put 26 sine of 49 degrees divided by the sine of 28. So I go back to my calculator and I would type that in. So 26 sine of 28 of, forgot what I was typing in, I gotta look. 26 sine of 49 divided by sine of 28. Because we're 100% relying on our calculator now, we know that we have to be very careful about typing it in correctly. To the nearest tenth looks like we get 41.8. So that is my side A. Once I have found all angles and all sides, my triangle solution is complete. And that's the law of sines. Let's turn the page, try another one. Same directions. Given your triangle, find all missing sides and angles. I kind of always draw the same triangle, despite the fact that once again I see angle C is obtuse. You can make yours look more accurate if you would like. So based off my given information, there's A and C. That's my pair of information. So it looks like I need to find angle A. So when we're looking for an angle, this is where your inverse trig comes into play. So I'm going to say the sine of angle A over 12 equals the sine of 122 for angle C over 18. Cross multiply, get the sine of angle A all alone. Everything here is proportion based, so we're going to do a lot of cross multiplying. Because we're looking for the angle on our calculator, we're going to do inverse sine, because we know the job of inverse is to find the value of the angle. Notice that this entire proportion comes in here. When we do that on our calculator, we're going to find the value for angle A. Still says round to the nearest tenth. So we are going to type that in. So inverse sine. So sine button, sine to the -1. So inverse sine, put your fraction in there so we can go ahead and get that value. So that's 12 sine of 122 degrees. Whoops, I'm not even in my, hold on, gotta clean this up and put it back in where it goes. There we go. 12 sine of 122 degrees divided by 18 gives us an angle value of 34.4 degrees. All right, so 34.4 is angle A. I'm going to write that over here. Once I know angle A, I'm going to go ahead and find angle B. So this is going to be 122 plus 34.4. Deduct from 180 because all angles add up to 180 degrees. And that's going to give us 23.6 degrees for angle B. Put that little degree symbol in there. Once I know angle B, I can go ahead and find side B. So one more proportion. I'm using the given from angle C, so sine of 122 over 18 equals the sine of B we found to be 23.6 degrees over side B. Cross multiply. So that's 18 sine of 23.6 divided by sine of 122. You would plug that in the calculator and that's going to give us 8.5. So to find our missing pieces for this triangle solution, this time we needed two angles and a side. Next question is an application. You'll notice there's going to be lots and lots of applications, hence the name of the packet. So word problems related to everything. Here we have I for Isaac and A for Albert. They spot a hot air balloon flying at low altitude. They decide to calculate its height, called h in our picture, by standing 400 feet apart and measuring an angle of elevation to the balloon. Remember, an angle of elevation is from the ground up. So Albert's angle is 62 degrees. Isaac's angle is 48 degrees. We want to determine the height of the balloon to the nearest foot. So first thing we're going to do here is we're going to look at the entire triangle. Because if I use my entire triangle, I'm using the 400 as the distance in between, and I actually can find the angle at the top by knowing that all three angles have to add to be 180. So that gives me this angle as 70 degrees. I am going to set up the law of sines, but I can't find h yet because that's in the inside of the triangle. So I'm going to find one of my sides. So I'm going to find the side across from Isaac. I'm going to call it little I because it is opposite the capital I for our angle. When I set this up, I'm going to use the 70-degree angle because it's opposite the 400 feet distance in between. I'm going to use the 48-degree angle, which is opposite my side that I'm calling I for Isaac. Cross multiply, and then we'll go to our calculator. I'm going to type this entire piece into my calculator, and that's going to give me an I value of about 316.335. There's a lot more decimals. You don't necessarily need to write them all on your paper, but you do need to use them as calculation for the piece that they want in the question. So don't lose your decimals. Next thing I'm going to do is I'm going to go inside the triangle. I'll trace this one in purple. If I go inside the triangle, then you'll notice, oh, I'm right back to a right triangle. So here is my triangle that I'm looking at. You could have used Isaac over there as well. Thought I'd use the angle A for Albert because it has side I for Isaac in there. And now I have a right angle. So you're welcome to use right triangle trig. Notice from the 62 degrees, we have an opposite and a hypotenuse. So I can do sine of 62 equals the height over letter I, and cross multiply that way. So my height is this 316 decimal times the sine of 62. Type that in your calculator, you'll get a height of 279.307 to the nearest foot. That's 279. Or if you really like law of sines, you can use it with the 90 degrees. So I could also have said sine of 90, which we know is 1, which is why it's going to give us the 1 right there. Sine of 90 is over I, and that's going to equal the sine of 62 over the height. Cross multiply, so since the sine of 90 is 1, when you cross multiply, you get the same exact piece of information. So you can use right triangle trig for this one, but you don't have to. Next question. A helium balloon-filled minion is anchored at the beginning of a parade route, awaiting the start of the parade. 2 cables attached to the underside. Oh, that shouldn't say penguin. That should say minion. Let's write minion there. Make angles of 40 degrees and 48 degrees with the ground. So first thing, we have 48 degrees. We travel 10 feet, and now we have 40 degrees. If the cables are attached by a 10-foot wire on the ground, how high above the ground is the minion? So we want his height. So here we have a little bit more work. First thing, inside the right triangle, we'll make this top angle 42, because that's 90 minus 48. This angle right here, if you remember your geometry, I'll highlight it. This is a supplementary relationship. So I could just do 180 minus 48. That gives me what? 132 degrees plus 40. So that leaves my top angle up here at 8 degrees. Okay. When you have a relationship like this, you're always going to start in the non-right triangle. Okay, so we're starting in that really skinny non-right triangle, and we're going to use the law of sines. I like to always, always, always find the shared side, so I'm going to call it x. Oh, I didn't spell that right. There we go. Okay, so that tells me that the sine of 40 degrees is opposite the x, and the sine of 8 is opposite the base of the triangle at 10. Cross multiply here. Divide by sine of 8. Go to your calculator. And this is going to tell us that our x value is 46.186. I like the dot, dot, dot because I can't round early. Okay, so this one is a don't round. We'll use that value to get into our right triangle. So the sine of 90 for the right angle is opposite the side we just found. And that's going to equal the sine of 48, which is opposite the height of the triangle. Since the sine of 90 is equal to 1, and I know that from my unit circle, h is really this 46.186 number times the sine of 48. Type that in, round to the nearest tenth, and our minion balloon is 34.3 feet above the ground. Okay, last question. We want to find, okay, draw a diagram to represent the fact that the angle of elevation from the ground to the top of the building. So here's my building. Okay, that's my building. The angle of elevation is from the ground up. So to the top of the building is 32 degrees. We're going to move 500 meters closer, so maybe we're right here. We've traveled a distance of, not 500, 50 meters, sorry. And we make a new angle of elevation to the top of the building, which is now 53 degrees. Buildings are always perpendicular to the ground. So you'll see here we've really created the same picture that we had in the minion question. First thing you should always do is find your missing angles. So 90 minus 53 is 37 degrees for the top angle there. To find the angle at the bottom here, we're going to do 180 minus 53. That's 127. That angle adds to 32 to get 159. Deduct from 180. That gives me a top angle of 21. Just like we said in the last question, our job is to find the shared side. So I'm going to call that side X. That X is opposite 32 degrees. And the sine of 21 degrees is opposite that distance of 50. Cross multiply. Divide. And if I put that on my calculator, I get 73.935. Keep your decimals because you don't want to round early. Finding that shared side now is going to take us into our right triangle so that we can find the height of the building. So I'm going to do the sine of 90, which is over the side we just found. That equals the sine of 53 over the height. So our height, once we multiply it out, looks like the height of this building is about 59 to the nearest meter, so 59 meters. For homework tonight, you are going to try the questions on pages 6 and 7. Check your answers in OneNote. Use a calculator. Just don't round early. So your calculator in degrees.